Hello all, welcome back to Sri Sai Tech Edu YouTube channel, Read, Lead, Success. I am dealing with the subject Network Analysis and Control Systems. I have already uploaded Module 1 to Module 5 topics in my channel. If you have missed out, please do watch. In Module 5, I've already done some of the topics. Today with a new topic, we will start this video. Already I completed till construction of root loci in the last video. In this video I will do the rules. What are the rules for the construction of root locus, and I will do a separate video for problems as the length of the video will increase. So what I'll do, rules I'll discuss in this video. After this I'll do one more video on problems which are related to root locus technique. So the first chapter of fifth module will be completed. In this video we will see the rules. Rules for the construction of root locus. There are totally 9 rules which are there for the construction of root locus. We will see one by one. First rule is the root locus is symmetrical about real axis. It is symmetrical about real axis. What is real axis? This is the real axis and this is the imaginary axis. What they are telling, the root locus will be symmetric along the real axis. The poles and zeros of any physically realizable closed loop system are either real or complex conjugate or combinations of both. That is, pole zero location is symmetrical with respect to the real axis of the S-plane. So the root locus must be symmetrical with respect to the real axis of the S-plane. What they are telling, the poles and zeros of any closed loop system are either what? Real or what? Or complex conjugate, or what? Both real and as well as complex conjugate. It can be both real and complex, or it can be only it can only be real, it can only be complex conjugate, or it can be both. So the pole zero location is symmetrical with respect to what? Real axis of the S-plane. So the root locus must be symmetrical with what? Root locus also will be symmetrical with the respect to the real axis of the S-plane. This is the first rule. Second rule, at the open loop poles k equals to 0, and at the open loop 0 k equals to infinity. If it is open loop poles, then k will be equals to 0. If open loop zeros, then k will be equals to infinity. Okay, if open loop poles, k equals to 0, the open loop zeros, k equals to infinity. So how it is, we will see. As the open loop gain k is varied from 0 to infinity. K is what? Open loop gain. Okay, is varied from 0 to infinity. Each branch of the root locus originates from an open loop pole k equals to 0 and terminates on an open loop 0 or 0 at infinity where k equals to infinity. The number of branches of root locus terminating on infinity equals to the number of poles minus zeros. Right? So the open loop transfer function of the system, the number of branches of root locus means what? On the infinity equals the number of open loop poles minus zeros. So the open loop transfer function of the system is g of s into h of s. We have already seen in the previous video also that open loop gain, k is what? Open loop gain, k into s plus z1, z2, these are zeros and these are poles. Therefore the characteristic equation is what? 1 plus g of s into h of s equals to 0. So 1 plus this g of s into h of s will be this equals to 0. Okay, so when k equals to 0, so when k equals to 0, what happens? Roots has, equation 6.5 has roots has s is equals to minus pj. Why? Because k will become 0, this whole thing will become 0. So s will be what? S is equals to, pj will go that side, so minus Pj minus Pj into that is nothing but j equals to 1 to n, where on the which are the open loop poles, which are what? Open loop poles. The root locus branches therefore starts at the open loop poles. The root locus will start now from poles. Why? Because we are getting p values. Why? Because k is 0. The characteristic equation can also be written as what? 1 by k pi of j equals to 1 to n s plus pj. Nothing but we are multiplying k to the where we want to have k to this. So what we can do? Multiply and divide k for this equation. What happens? Multiply and divide that equation by k. What happens? So this can be multiplied here. 1 by k into this. So like that, k is nothing but they are taking k common. See, if you take common here, k common, here you need to multiply 1 by k. No, then only k get cancelled and again you get the back equation. So what we are doing? We are just removing common from this k. So after removing common, what you will get? 1 by k and the poles equation and zeros equation equals to 0. When now k equals to infinity, the first term becomes 0. 1 by infinity is what? 0. So becomes 0 and the roots are located at, if this becomes 0, then this what happens? S is equals to minus zi, I equals to 1 to n, which are the given zeros of the system. Therefore, m branches of the root locus terminates on the open loop 0. They terminate at open loop 0 and they start at open loop poles. So in case this n is greater than m, the open loop transfer function has n minus m zeros at infinity and n minus m branches of root locus terminate on these 0. See, once again I will do a quick recap. See, what they are telling is open loop poles will be 0 at when k is equals to 0 and k equals to infinity, open loop zeros. And at the open loop zeros, k is equals to infinity. How we will do that? We know the transfer function. We will write that is equals to 0. We will add the g. We will substitute g of s into h of s, and we will initially consider k equals to 0. When consider k equals to 0, then you are left with what? S plus pi. This term you are left. So s will be equals to what? Minus pj, which are what poles? Which are the open loop poles. So the root locus branches therefore start from open loop poles. So we made now k equals to 0 for z. So what we can do, if you want, we can take k common to this. When you take k common, 1 by k, here you need to divide it by k. 1 by k plus, so as k is taken out, it is taken out and it is sent right side. Anyway, it is 0, the k will be gone. So you are left with this. Now if you put k equals to infinity, this becomes 0 and you are left with what? Zeros. So s will be equals to minus zi and I will be equals to 1 to n. So which are given zeros of the system. So m branches of the root locus terminate open loop zeros on the open loop 0. Here what? Here starts at the open loops, here terminates. So in case if n means nothing but the poles are greater than zeros, then the open loop transfer function has n minus m zeros at infinity and n minus m branches of root locus terminate on the zeros. They have n minus m zeros at the infinity and n minus m branches of root locus terminate on these zeros. Okay. Third rule. Segments of the real axis having an odd number of real axes, open loop poles and zeros to the right are the parts of the root locus. Segments of the real axis having an odd number of real axes, open loop poles and zeros to the right are parts of the root locus itself. So each pole and zero on the real axis to the right of any point on the real axis, right on the real axis contribute an angle of 180. See, poles and zeros, they contribute 180. Right? That is what they tell you. The angle of 180 with respect to that point, and each pole and zero on the real axis to the left of any point on the real axis contributes an angle of 0 degree with respect to that point. 0 and 180. 0 to that point, the net angle contribution of a complex conjugate pole or a 0 is always a 0. The net angle contribution of a complex conjugate pole or a 0 is what? 0 itself. So figure 6.5 shows the angle contributions for a point on the real axis. So see, this is a pole. This is a 0, and this is a P is nothing but pole. Here it is 180, here it is angle is 0 if you observe. So for the root locus to exist at any point in the S plane, the phase angle condition, that is, we have the condition called angle G of S into H of S equals to plus or minus 2q plus 1 into pi must be satisfied, right? That should be satisfied. This condition can be satisfied at any point on the real axis if the total number of open loop poles and zeros to the right of that point is odd. This condition will be satisfied at any point on the real axis when if the total number of open loop poles, these poles and zeros to the right of that point is odd. To right of the point is odd. If they are odd, then this condition is satisfied. Fourth rule. The n minus m branches of the root locus which go to infinity travel along a straight line asymptotes whose angle are given by theta q equals to plus or minus 2q plus 1 into pi. This is what? Phase angle condition by n minus m. Q is nothing but 0 to n minus m minus 1 value. See, n minus m is what? N is nothing but poles. M is taken for zeros from previous rule. So, if the root locus the branches of root locus goes to infinity, travel along straight line asymptotes whose angle given by what? This is the equation. Consider at any point on a branch of the root locus which is far away from the open loop poles, which is very far away from the open loop poles which are present. Okay, and zeros. Open loop poles or zeros, it is very far away. Any point of branch which is far away from the poles or zeros which is present nearer, the phases drawn from such a point to all the poles and zeros make the same angle theta to each open loop pole and zero. So, if a phasor is drawn from such a point where it is very far, then all the open poles and zeros make what? Same angle theta. It will make same angle theta to each open loop pole and zero. To each open loop pole, it will make same angle. If we draw a point, a phasor from that point, therefore, at the point considered, angle G of S into H of S minus of n minus m into what? Theta. Minus n minus m into theta. For the root locus to exist at this point, to exist a root locus at this point, minus of n minus m theta, that should be equals to what? The angle. That is nothing but plus or minus 2q plus 1 into pi. If you take this side, again in this equation you will get. Since the n minus m branch of the root locus goes to 0 at infinity, what they go? 0 at infinity. The angles of the asymptotes are what? This is the equation. Okay, this is the equation. This is fourth rule. Fifth rule. The asymptotes cross the real axis at a point known as centroid determined by the relationship. Asymptote cross the real axis at a point known as centroid determined by the relationship. Usually asymptotes are called what? Means if there is a plane like this, for a curve it doesn't touch, but it goes to infinity. This is called a asymptote, where it doesn't touch a curve which doesn't touch or cross never touch or cross as it extends towards what? Infinity or a specific point, to a specific point or infinity. But what they're telling here, the rule, the asymptotes will cross the real axis at a point. It will cross the real axis. What it means is, if this is an asymptote, this crosses the real axis. So this point at a point known as what? This point is called what? Centroid, determined by a relationship. It has a relationship. That relationship is what? This is centroid by the asymptote. The centroid has a relationship, that is minus sigma, we say, equals to sum of real parts of the pole, sum of real parts of the pole, sum of real parts of zeros by number of poles minus number of zeros will give the centroid value. That centroid value you will get how? When sum of real parts of poles minus sum of real parts of zeros by number of poles and number of zeros are subtracted, then you will get the centroid value. Then the rule 6. The breakaway points and break-in points. The breakaway points and break-in points, points at which multiple roots of this characteristic equation exist, of the root locus, are the solutions of the breakaway points and break-in points, which are the points with multiple roots of characteristic equation exist of the root locus, are the solution of what? dk by ds is equal to 0. K is what? Open loop gain. So the breakaway point and break-in point may be real or what? Complex. It may be real or it may be complex. This is real, no? This is minus sigma and this is what? Is j omega. Right? It can be real or complex. So the break angles. The root locus branches must approach or leave the breakaway point on the real axis at an angle plus or minus 180 degree by r, where r is the number of branches approaching or leaving the breakaway point. They are approaching or leaving. R is what? Approaching or leaving. Plus or minus 180 by r will give what? The root locus branches must approach or leave the breakaway point on the real axis at an angle what? 180 by r. R is number of branches approaching and number of branches or leaving. Branch angles. 7th rule. The angle of departure from an open loop pole is given by theta d is equals to plus or minus 2q plus 1 into pi plus phi. Q equals to 0 to 1 to continuously till infinity. The angle of departure from an open loop pole is given by what? This. Here, this phi is the net angle contribution at the open loop pole of all the open loop poles and the zeros. Net angle, total angle. Similarly, the angle of arrival at an open pole is given by, the angle of departure is given by this. Angle of arrival, theta A, is given by plus or minus q plus 1 into pi minus phi. Phi is the net angle contribution at this open loop 0 of all the open loop poles and zeros. See, if you need to notice some differences whenever you are studying your subject. See, angle of departure, angle of arrival, theta d and theta a. Here plus or minus 2q plus 1 is same, pi also same. Here plus q plus phi y, it is angle of departure, it is leaving, departure. So plus phi. So the net angle of at the open loop pole they are telling, okay, of all the open loop poles and zeros. Here minus phi as it is angle of arrival, and this is phi is what here? Here net angle contribution at this open loop 0 it is. For all the open, for all other open loop poles and zeros. You need to remember in this way. Rule 7 it is. Next, the angle of departure and the angle of arrival need to be calculated only when there are complex poles and zeros. The angle of departure from a real open loop pole, the angle of arrival at a real open loop 0 is always equals to 0 or 180. See, the angle of departure and angle of arrival when we need to calculate? When there are complex poles and zeros present. Complex if they are. The angle of departure from a real open loop pole and the angle of arrival at a real open loop 0 will be always equals to 0 or either 180 degree. Figure 6.9 illustrates the calculation of angle of departure and illustrates the calculation of angle of arrival. See, 6.9, this is the angle of departure. Angle of departure, if you see angle of departure here, phi is equals to theta 3 minus theta 1 plus theta 2 plus theta 1 plus theta 2 plus theta 4 plus theta 5. Nothing but we are subtracting theta 3 minus this. So theta d will be, you can substitute this phi in this. And here if you see, phi is what? Theta 3 minus theta 2 plus theta 1. The values are also given. How exactly the departure is calculated. Here if theta 1 is 135 and theta 3 is 26.6 and theta 2 is 90. What we are doing? Theta 3 26.6. Okay, 26.6 minus what we are doing? Theta 2 plus theta 1. Theta 2 is what? 90 plus 135. Then you will get minus 198.4. So if you substitute here 2q plus 1 into pi, as it is told, it will be 180. So 180 minus 198.4, you will get minus 18.4. Okay. See, the same way here, angle of arrival we are calculating. How it is calculated? See here. See, phi is equals to theta 1 minus theta 2 plus theta 3. Then arriving. So arriving means first we should take theta 1, then theta 2 plus theta 3. Then if you see for sum wise, see first theta 1 90 minus 135 plus 26, you will get minus 71. 180 minus of 71, you will get 251 as degrees. Calculation angle of arrival. Angle of arrival. Okay. Angle of arrival will be calculated in this way. Angle of departure will be calculated in this way. Departure, we should take first theta 3. Why? Because there is only one. What here? 0. And next poles we are adding here. You should carefully understand this. Again here also, first what we are taking? The zeros first. Zeros we are minusing with what? The same way what I have told. 0 minus pole. Poles are what? Poles are, these are the poles. So theta 3 plus theta 2. Then only you will get the correct answer. First zeros we should take, minus of the poles. 8th rule. The point of intersection of the root locus branches with the imaginary axis and the critical value of k can be determined by use of root criterion. Once again I will repeat, the point of intersection of root locus branches. The root locus branches are present, no? The point of intersection of those root locus branches with what? With the imaginary axis, and the critical value of k can be determined by what? Use of root criterion. How this? I will explain with this example. See, these are the what? Root locus branches based on the poles and zeros you think. Based on this, based on the imaginary axis, the value of critical value k can be determined. The value of k, open loop gain. Open loop gain can be found by using what? Root criterion. As we have already seen in module 4 what is root criterion. But once again I will explain here with an example so you will get a great clarity here. See, s into s plus 1 into s plus 3. If you multiply this inside, you will get in this form. Then based root criterion, how you will write? First with the s power 3 highest. So s power 3, s power 2, s power 1, s power 0. Then you write 1, then 4. The 3 coefficient here, k is the coefficient. After writing, what you will do? 4 into 3, 12 minus 1 into k by this 4. 12 minus k by 4. And next 12 minus k by 4. 12 minus k by 4 into k minus 0. Minus 0. What you will get? 12 minus k by 4 into k minus 0. 12k minus k square by 4. So lastly, if you calculate this, no, you will get lastly what? K as the value. Okay, this again what you will do, this into this. See, 12 minus k by 4 into k minus 4 into 0 anyways, 0 by 12 minus k by 4. This and this get cancelled, you are left with what? K. Understanding? So till root criterion we are done. So what you can see, this k is what? Greater than 0. So for all the roots of the characteristic equation to lie left of the imaginary axis, the following condition should be satisfied. The k should be greater than 0. So 12 minus k by 4 greater than 0 means what? You will get k will be less than 12. So the critical value of k, which corresponds to location of roots on JW axis, is given by 12 minus k by 4 equals to 0. Then k will be equals to 12. Or the value of k equals to 12 makes all the coefficients of S1 row of the root array 0. Okay, for this value, the auxiliary equation formed from the coefficient of S square row is given by, see, if k value is 12, then what happens? There is some problem. Why? Both it will become 0. This also will become 0 and this also will become 0. So this you can write in the form of auxiliary equation. How? 4s square, and you should not write again k s power 1. You should write k. Right, so k is 12 anyway. 4s square plus 12 equals to 0. So 4s square equals to what? Minus 12. So s square will be minus 3. So s is equals to plus or minus j root 3 you can write. So thus for the root locus plot in figure 6.7, the branches intersect the j omega axis at s is equals to plus or minus j root 3, and the value of k corresponding to root is 12. How it is? Then the value of the open loop gain k at any point S0 on the root locus is given by the value of the open loop gain k at any point S0 on the root locus is given by how? This is the ninth rule, that is k equals to product of lengths of vectors drawn from that point S0 to all open loop poles by product of lengths of vectors drawn from that point S0 to all open loop 0. Okay, the characteristic equation is what? 1 plus g of s into h of s equals to 0. So g of s into h of s mod is what? Equals to 1. K into s plus z1 into s plus z2 so on by s plus p1 into s plus p2 equals to 1 we can write. So k value will be what? This. These are nothing but product of phasor lengths of S0 to open loop poles, S0 to open loop 0. This is what is similar to one of the rule what we have studied previously. So how many rules we have studied? 9 rules. We will do a quick recap now. The root locus is symmetrical about the real axis, and each branch of the root locus originates from an open loop pole when k is equals to 0 and k equals to infinity when it is terminates on the open loop 0 and when k equals to infinity. Segments of the real axis having an odd number of real axis, open loop poles plus zeros to the right are the parts of the root locus. Then this is what the theta, that is making angles for the straight line asymptotes. Then the point of intersection of the asymptotes with the real axis centroid you can calculate using this formula. The breakaway points and break-in points is found using what? Open loop gain. The angle is what? Plus or minus 180 by r. R is nothing but number of either coming towards either they are poles or coming arrival or departure of the poles or zeros. The angle of departure from an open loop pole is given what? This is departure and it is the arrival. Then the point of intersection of the root locus branches with the imaginary axis and the critical value of k can be determined by the use of what? Root criterion. You can find the k value. Then the open loop gain k in pole 0 form at any point S0 on the root locus is given by what? Product of phasor lengths from S0 to open loop poles, product of phasor lengths from S0 to open loop zeros. These are the 9 rules for the construction of root loci of 1 plus g of s into h of s equals to 0, where the open loop transfer function g of s into h of s is known in pole 0 from n is equal to number of open poles and m is equals to number of open loop zeros. N is what? Number of open loop poles. M is what? Number of open loop zeros. So these all rules are important. There are chances that they may ask write all the 9 rules, explain all 9 rules in exam. So please study well. And now the root locus technique is done. Based on this, there are some problems how to construct root locus as the length is increasing. So I am doing the separate video for the problems on root locus technique after this next video, that is part 4. So for now, I'm stopping the video here. Thank you. From Sri Sai Tech Edu YouTube channel, Read, Lead, Success. Keep reading.